Hi everyone, this is going to be for your Algebra 3 questions on problem set 56. Now I received a lot of questions from this lesson, but a lot of you posted questions on numbers 9 through 13, and that was actually all answered already on the lesson video for lesson 56. So you need to go back and watch that video because it kind of shows me that you guys didn't pay attention since I already went over those questions. So numbers 9 through 13 I'm not going to do in this video because I've already gone over them in the lesson 56 video. But we're going to start on number 3. Number 3 says how many distinguishable permutations can be formed from the letters in the word irrigator? Well, in the word irrigator, I have multiple letters that I need to take care of. So I'm going to start with counting how many total letters I have. So my total letters is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a total of 9 letters. And then I have to go through and count my multiples. So if I look at the letter A, there are 2 A's. If I look at the letter R, I have 1, 2, 3 R's. And then if I look at the letter O, I have 2 O's. So the formula I'm going to look at is distinguishable permutations equation, which is actually n factorial over the number that are like factorial. So this would be a factorial, r factorial, and then o factorial. The n is just going to be the total number of letters. So my total number of letters is 9 factorial. That's going to be divided by 2 factorial, 3 factorial, and then 2 factorial. So when you're multiplying this out, we have 9, 8, 7, 6, 5, 4, 3 factorial over 3 factorial times 2 times 1 times 2 times 1. Well, if I do that, the 3 factorial cancels, and then 2 times 2 is actually 4, so I can cancel that out as well. So I am left with 9 times 8 times 7 times 6 times 5. My answer would be 15,120. So distinguishable permutations means we have to take out the double letters in the equation, so that's why we divide it by the number of doubles. Now moving on to number 4, the wheels on Susie's car were revolving at 40 revolutions per minute. What was the velocity of the car in centimeters per second if the wheels had a radius of 10 inches? So we have the equation for number 4, V equals RW. So it says how fast the wheels were revolving, which is the angular velocity, and we know what the radius of the tires is. It says the radius is 10 inches. So I'm going to plug into this equation. That would be 10 inches, and then multiply by the angular velocity, which is 40 revolutions per minute. Now the first thing that I'm going to do is actually to get rid of this revolution right here. Revolution is not the one you can cross out as needed, that's radian. So what I'm going to do is I'm going to multiply this by 2 pi over 1 revolution. And that's going to cancel out the revolution. Now all I need to focus on is getting this from inches to centimeters and minutes to seconds. So that can be done in 1 unit multiplier because inches goes to centimeters. There's 2.54 centimeters in 1 inch. And then that cancels out my inches. Then I can convert from minutes to seconds by doing 1 minute is equal to 60 seconds. And now I can just rewrite my answer. So my answer is going to be 10 times 40 times 2 pi times 2.54 all over 60, and that's going to be centimeters per second, and that would be your answer. Now moving on, we're going to look at number 5. Number 5 is the same type of problem. It says the Formula One car came by at a speed of 260 kilometers per hour. If the wheels had a diameter of 2 feet, what was the angular velocity in revolutions per minute? So the equation that we're starting with for number 5 is V equals RW. But what we're trying to solve for is the angular velocity. So to get this angular velocity by itself, we're going to multiply both sides by 1 over the radius, which means that angular velocity is going to be equal to velocity times 1 over the radius. And now what I'm going to do is input the values that I'm given. So it says that the speed of the car would be 260 kilometers per hour. So that's my velocity, 260 kilometers per hour. And then my radius, well, the diameter is 1 feet, so that, or 2 feet, so this radius would be 1 foot. So what I want to do first is I actually want to get rid of the kilometers and the feet and then convert hours to minutes. So kilometers to feet is going to take quite a few unit multipliers. So we're going to do feet to inches. So that would be 1 foot, 12 inches. Then I have to go inches to centimeters. So 1 inch, 2.54 centimeters. So the inches cancel, the feet cancel. Then I need to go centimeters to meters. So that would be 100 centimeters in 1 meter, and the centimeters would cancel. I'm going to go down to the bottom because it doesn't fit, but I'm going to have 1,000 meters, 1 kilometer. Now the meters, notice, is in the denominator, so that would cancel. And the kilometer, I have 1 in the numerator, 1 in the denominator, so that would cancel. Now you're thinking, well, now I don't have a unit of measurement, but we need it to be in revolutions per minute. So what I'm going to plug in here is the unit multiplier. 1 revolution is equal to 2 pi. Now I have my unit of measurement, and I'm left with just converting from hours to minutes. So 1 hour over 60 minutes. Again, this is in the numerator, that's in the denominator. And now I just need to rewrite my answer. I know it's a little confusing because I have to go to 2 lines, but this would be 260 times 100 times 1,000 over, now I have 12 times 2.54 times 2 pi, and then times 60, and that's going to be in revolutions per minute. Okay. So again, that all stems from the equation velocity is equal to angular velocity multiplied by the radius. Now we're going to look at number 6. Number 6 says Hannibal was paid $450 for a 30-hour week. He wanted his wages raised 10% and wanted to work more hours. His boss gave him the 10% hourly raise and increased his weekly hours to 36. What was his weekly paycheck now? So what we're going to start by doing is finding how much did Hannibal make per hour. So we take his $450 and divide that by the 30 hours that he worked. Which means that he made $15 an hour. But he wants that 10% raise, and he got it. So what we need to do to this $15 is multiply that by 110%, or 1.1. And that would be his normal wage plus 10%. So I'm going to multiply this by 1.1. And he is now going to be making $16.50 per hour. And he's also going to be working 36 hours. So I need to multiply his hourly wage by how many hours he's working, which is 36. And that tells me that he is now going to be making $594 a week. Okay, so that's one of the concept review problems that you're not going to be tested over. Now we're going to move on to number 7. It's one of these old word problems that we haven't done in a while. So it says, The sum of the digits of a 2-digit counting number is 11. So that means that the tens plus the units digit is equal to 11. This is number 7. And it says when the digits are reversed, the new number is 27 less than the original number. Well, the reversed equation, if you don't remember, have it in your notes, is 10u plus t. And it says is 27 less than the original, and the original equation is 10t plus u, and 27 less than that. So if you don't remember how to do these problems, this is the reversed equation, this is the original equation. Now I'm going to bring the t to the left and the u to the left. So that would give me negative 9t plus 9u is equal to negative 27. But I can actually simplify this equation by 1/9. So if I divide this whole thing by 9, my equation is going to be negative t plus u is equal to negative 3. Now I can easily add this to my original equation of t plus u is equal to 11. And when I do that, the t's are going to cancel, and you get 2u is equal to 8. And therefore I know that my units digit is equal to 4. If my units digit is equal to 4, then my tens digit is going to be equal to 7. And it says, what was the original number? Well, if the original is a tens digit is 7 and the units digit is 4, my original number is going to be 74. Now we'll move on to number 8. The ancient one is 40 years older than the youngster. 10 years ago, the age of the ancient one was 22 years greater than the 7 times the age of the youngster then. How old are both of them today? So we have the ancient one and then we have the youngster. So for number 8, I'm going to use the variables a and y for their current ages. Then 10 years ago, I'm going to use a minus 10 and y minus 10 for 10 years ago. These are the variables that I'm going to use for this problem. So the ancient one is 40 years older than the youngster. So a is 40 years older than the youngster. Then it says 10 years ago, the age of the ancient one, so a minus 10, was 22 years greater than 7 times the age of the youngster then. So that would be 7 times y minus 10, but 22 years greater than that, so plus 22. Now I have 2 equations. What I'm going to do is I'm going to actually do substitution. I'm going to plug in this 40 plus y into for a. So that would be 40 plus y minus 10 equals 7y minus 70 plus 22. Now I can move this 7y over to the left, which would give me negative 6y. And then 40 minus 10 is 30, so I'm going to subtract 30 from the other side. So I have negative 70 minus 30 and then plus 22, which would give me negative 78. Which means that the age of the youngster is currently 13 years old. And then it says, what's the age of the ancient one? You would take that 13 and plug it into here. So that means the ancient one is going to be equal to 53 years old. Okay, now moving on, we're going to look at number 15. Number 15, we have this equation, y equals x squared minus 4x plus 6. So the first thing that we're going to do is we need to complete the square. So I'm going to put everything that contains an x into parentheses. And then leave the 6 on the outside. Now when I complete the square, I have to take half the term that's attached to x. Now half that term would be x minus 2. When I square that, though, it becomes plus 4. So when I fill in the space up above, remember that you have to do the opposite to the outside. So if I add 4 to the inside, I'm going to do the opposite to the outside, which is to subtract 4. That will give me plus 2. Now this outside is positive, so I know that it's going to be a parabola that's going to face up. The x minus 2 is my axis of symmetry, so I set that equal to 0. And that will give me that the axis of symmetry is at 2. And my vertex, where my parabola is going to start, is also going to be at 2. Now I'm going to use this chart that I've said before, which is 1, 1, then 2, 4, 3, 9. And now I'm going to draw my diagram. So the first thing I'm going to do is put my axis of symmetry, which is a dotted line, at x is equal to 2. Then I'm going to put a point at my vertex, which is at positive 2. I know it's going to face up, the parabola is going to face up, so from my vertex, I'm going to go over 1, up 1 in both directions, and then over 2, up 1, 2, 3, 4. And then you need to connect the dots. And that would be what your parabola should look like. So find out if this is a positive or a negative parabola. Then you need to plug in your axis of symmetry, which is always a dotted line. And then you need to find your vertex, which is always that value on the outside of the parentheses. Now moving on, we're going to look at number 17. So for number 17, I have tangent theta is equal to -1. So the first thing that I'm going to do is I can always put my numerator over the value 1. So I have -1 over 1. Now I'm trying to find in which quadrant is tangent going to give me a negative ratio. So I have all students take calculus. I know that tangent is positive in both quadrants 1 and 3 because A is all and then T is tangent, which means that it's negative in quadrants 2 and 4. Now this is going to be my opposite over adjacent, so this would be -1 over 1. This one I have to flip it to 1 over -1. Now what kind of triangle is that? Where the opposite and the adjacent are 1. That means the hypotenuse is √2. And therefore, this angle here is a 45-degree angle. When we're in quadrant 2, though, we need to know the distance from 0 degrees to that point. So we're going to do 180 minus 45, which is going to give me 135. And then for quadrant 4, I have to subtract it from 360 because remember, it has to be a positive degree. So 360 minus 45 would give us 315. And those would be your two answers. So this one, because when you put the -1 over 1, it's still going to be a reference triangle. We're not going to use the unit circle on that one. Now we're going to move on to number 18. So for number 18, we have tangent of 3 theta. And I'm going to move the √3 over 2 to the other side. So that would be sine 3 theta equals -√3 over 2. Now I need to solve for where is sine going to be negative. I have all students take calculus. I know that everything's positive in quadrant 1 and sine is positive in quadrant 2. So that means sine is going to be negative in quadrants 3 and 4. Now this is opposite over hypotenuse, so my opposite would be -√3, and my hypotenuse would be 2, which leaves my adjacent to be 1 and -1. But most importantly, that just tells me what this angle is going to be. Now don't forget about your inviolable argument. So I'm going to set 3 theta equal to the first degree, which if this is 60 degrees, I need to subtract that or add that to 180, which would be 240. And then for my second one, 360 minus 60 would be 300. Which means that my first answer for quadrant 3 is going to be 80. And my first answer for quadrant 4 is going to be 100. But remember that you need 3 answers for each quadrant. So you're going to set 3 theta equal to 360. When you divide both sides by 3, you get that theta is equal to 120. Now this is what you're going to continuously add until you end up with 3 answers for each quadrant. So 120 plus 80 would be 200. 200 plus 120 would be 320. 100 plus 120 would be 220. And 220 plus 120 would be 340. And this would be your 3 answers for quadrant 3 and your 3 answers for quadrant 4. Now moving on, we're going to look at number 19. So for 19, we have cosecant of 2 theta is equal to -1. Cosecant of 2 theta equals -1. So I can always put this over 1. And I don't have a reference triangle that has a hypotenuse of 1 and an opposite of 1. So I know that I'm going to start looking at my unit circle, and I'm going to draw this out. So 1, 0, 0, 1, -1, 0, and 0, -1. Now, cosecant is the inverse of sine. So if sine is y, this would be 1 over y. Now, for 1 over y to be equal to -1, that means my y is going to have to be -1. So I'm looking for where my y coordinate is equal to -1. And there's only one place that that happens, and that's at 270 degrees. So what I'm going to do is I'm going to set 2 theta equal to 270 degrees, and that will give me my first answer. So my first answer is going to be theta is equal to 135. But remember that I'm going to have 2 answers. So I'm going to set 2 theta equal to 360. When I divide that by 2, I get theta is equal to 180. And remember, this is what you're going to add to your answer of 135 to find your second answer. So 135 plus 180 would give us 315. And those would be your 2 answers. Okay, so that one you have to use the unit circle because you didn't have a reference triangle that had a hypotenuse of 1 and an opposite of 1. Now moving on, we're going to look at number 23. So number 23 says use the locus definition method to write the equation of the line which is equidistant from -2, 4 and -4, -4. Write the equation in general form. So the locus definition method is going to be the x minus x1 squared plus y minus y1 squared equals x minus x2 squared plus y minus y2 squared. So I'm going to start by plugging in my variables. So this would be x plus 2 squared because x minus x1 plus y minus 4 squared equals x plus 4 squared plus y plus 4 squared. So it's x minus x1 squared plus y minus y1 squared equals x minus x2 squared plus y minus y2 squared. So now what we're going to do is we are going to multiply this out. So this would give me x squared plus 4x plus 4 plus y squared minus 8y plus 16 equals x squared plus 8x plus 16 plus y squared plus 8y plus 16. Now there's multiple things that could cancel. I can cancel out my x squareds and my y squareds from both sides, but I can also cancel out one of the 16s. To set this in general form, we're going to set this equation equal to 0. So I'm going to move the 8x over to the left. I'm going to move the y over to the left. And I'm going to move this 16 over to the left. which means that I end up with negative 4x minus 16y minus 12 is equal to 0. And we can actually simplify that equation by, I'm going to simplify it by 4. Or you could actually simplify it by negative 4 to give you an equation of x plus 4y plus 3 is equal to 0. And that would be my answer. Now for number 24, it says find the coordinate that's halfway. So really all this is asking for is the midpoint formula. And the midpoint formula is this: x is equal to x1 plus x2 divided by 2, and then y is equal to y1 plus y2 divided by 2. So my x1 is going to be 4, my x2 is 12. So 4 plus 12 is 16 divided by 2 is 8. Then for y, I have 7 plus negative 3 divided by 2. So 7 minus 3 is 4 divided by 2 is 2. So your answer is just 8, 2. All that was the midpoint formula. So find the point that's halfway is the midpoint formula. Now moving on, we're going to look at number 26. So the first thing that we're going to look at for number 26 is I know that my answer, so this is going to be 3x squared plus 18x plus 30. I need to start by factoring out any number that's common among all three terms, and that term would be 3. So I have x squared plus 6x plus 10. Now my answer is going to be of the form x minus root times x minus root. So I need to find the roots of this equation right here. And the way I'm going to do that is by doing quadratic formula. So I'm going to start quadratic formula down here. So it would be x is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So that's going to give me negative 6 over 2 plus or minus, and that would be 36 minus 40. So 36 minus 40 is going to be negative 4. So it would be the square root of 4i over 2. Now negative 6 divided by 2 is negative 3. And the square root of 4 is 2. So 2 divided by 2 is just going to give me I. So I have two roots. I have negative 3 plus I and I have negative 3 minus I. Now when I plug it into this formula right here, don't forget that you factored out the 3, but when you plug in the roots, you're going to change the sign. So this negative 3 is going to change to positive 3. The positive I is going to change to negative I. Then the negative 3 is going to change to positive 3. And the negative I changes to positive I. So your answer is 3 times x plus 3 minus I times x plus 3 minus or plus I. If you were to multiply that all back out, you would end up with where you started with the 3x squared plus 18x plus 30. Now we're going to look at number 29. So for number 29, I have log 2 of 128 equals x. So to get rid of the log 2, what I'm going to do is I'm going to raise both sides to the power of 2. So it would be 2 to the log 2 and then 2 to the x. So I have 128 equals 2 to the power of x. So what they're asking for is 2 to the power of what is equal to 128. And we're going to use our calculator for that. So I know that it's going to be between 2 to the power of So it's going to be between 2 to the power, oh, well, if you plugged it into your calculator, 2 to the power of 7 is equal to 128. So you could just plug it in and check. So this is actually equal to, x is equal to 7. So all I did was kind of guess and check. So I did 2 to the power of 6, and that was 64, and then I tried 2 to the power of 7, which is 128. Now moving on to b. So for b, I have a number outside my logarithm, so that's going to become the exponent. And that would become log 27 to the 2/3 plus log x is equal to log 12. Now 27 to the 2/3, I'm going to do my calculator. So set 27 to the power of 2 divided by 3 equals, and that's 9. If I have a plus sign, I'm going to multiply these two together, so that would become log 9x equals log 12. Now to get rid of the log on both sides, there's no base, and whenever there's no base of log, you assume the base is 10. So this would be 10 to the log 10, 10 to the log 10, that's how it cancels. Now you have 9x is equal to 12, and you can divide both sides by 9. So x would be equal to 4/3. And lastly, we're going to look at number 30. So for number 30, it is a tricky one because what we're going to be doing is we're going to start by plugging in x plus h into this equation, then plugging in x minus h into this equation. I'm going to do these in separate pieces. So I'm going to start with, so f of x plus h I'm going to do in brown. Then this is going to be my minus, and this is all going to be over 2h. And then in purple, I'm going to do my f of x minus h. So for the brown portion, I'm going to start by plugging in x plus h into wherever I see an x in this equation. And that would give me x plus h times x plus h minus 2. Okay, so that's just this portion, just the f of x plus h. I replace the x's with x plus h. Now my green portion is going to stay the same. But my purple portion is going to change because I'm going to plug in x minus h into that equation. So that would become x minus h times x minus h minus 2. Now I need to multiply this out. So I'm going to start with the brown. So I have x times x would give me x squared. X times h would give me xh. X times negative 2 would be negative 2x. Then x, or h times x would be xh. H times h would be h squared. H times negative 2 would be negative 2h. Then it's going to be minus this is going to be in parentheses. So x times x would be x squared. X times negative h would be negative xh. X times negative 2 would be negative 2x. Negative h times x would be negative xh. Negative h times negative h would be h squared. And then negative h times negative 2 would be plus 2h. But now I'm going to look at my brown portion. So I can actually add these two xh's together, and that would give me x squared plus 2xh minus 2x plus h squared minus 2h. when I distribute my minus sign, this is going to become negative x squared. I can combine the negative 2xh, but it would become positive 2xh. The negative 2x times negative would be positive 2x. Positive h squared would change to negative h squared, and 2h would turn into negative 2h. That would all be over 2h. So I distributed my minus sign into that parentheses, and now I'm just going to simplify. So you should see that your x squareds are going to cancel. Your h squareds are going to cancel. My 2x are going to cancel. Then I'm left with 2xh plus 2xh would be 4xh. And I have negative 2h minus 2h would be negative 4h all over 2h. Now we can actually cancel out all those h's, and everything's divisible by 2. So 4x divided by 2 would be 2x, and 4 divided by 2 is just 2. And your answer would be 2x minus 2. And that concludes your questions from lesson 56. I hope you all have a great day. Bye.